Hi everyone, I'm Michael Perch. I'm a professor from the University of Texas at Austin. And Brian Romans, a professor from Virginia Tech, gave a challenge on Twitter, said, what can you do to support a geoscientist who wants to get started with Python, but will find a bit of a hurdle to just get going, to get things, break the ice. And so I thought, well, what can I do to support that? And so what I'll do in this video is I'll try to walk through in the most intuitive, simple manner I can the idea of getting started with a little bit of Python. Okay, so let's get started. What is the first thing that we would want to do? Well, if you have a Reg or Macintosh, first thing you want to do is go to Anaconda.com right here. And what you'll see is if you scroll down here, you can download the Anaconda distribution. So let's go ahead and click on that. And if we go, we'll see we have two major options here. The first one is, well, first of all, we can pick Windows or Macintosh, and we can then make a selection between Python 3.7 and 2.7. Now we're reaching a point right now where Python 2 is becoming a bit out of date. Many packages aren't maintaining it anymore. Anything above 3 would probably be the best thing to do right now. Of course, this video, if it sits out there in the interspace, I'm sure we'll reach a point where this will seem old-fashioned. Just pick the most current version of Python. Go ahead and download it. You can save the file. You can install it. I'm not going to do that because I've already installed this. Now, once you've done that, you can go down to in Windows, you have the selection bar at the bottom, and you can go ahead and type in Navigator. And you'll see that the Anaconda distribution includes a bunch of programs, including Navigator. Navigator is really useful. You can use it to see what packages are installed. A little bit of time to install and to load up the Navigator. Let's go ahead and open it up. So let's go ahead and we can look at what we have available to us. You can go into it and see immediately that you have a variety of different programs that are available to you within the Anaconda install. We're going to be using Jupyter Notebook, but you could of course also use Jupyter Lab. I won't talk about that. You've got a Spider, which is more like a Python IDE, which allows you to do your coding, to test your code, to check your code. It helps you. IDE is a integrated development environment. Now what we'll show today is in Jupyter Notebook. You have VS Code, which also provides you a really nice code editor, which actually is pretty useful. And interesting, RStudio is also included. For those out there that are interested or curious or have used R before, that's also available within this install. Okay, so another thing we can do is if we go to environments, you can go to your base install and you hit this plus arrow right here. From here we can open a terminal. We could go ahead and run Jupyter Notebook. Let's just open a terminal right now. I'm going to show you something. Now, if you want to do geoscience, geostatistical types of things with Python, you're going to want to install, and this is self-serving. This is my package. It's GeostatsPy. The way you install is very straightforward. You just type in pip install GeostatsPy. Now, the reason we went here and got the terminal here in the Navigator is that assures us that when you run Jupyter, this package is going to be in the right place and you'll have access to it and be able to use it. I'm not going to run this as I've already installed on this machine, but if you run this, there will be a bunch of things that happen. It'll install the package, and so we can now move on. Now, you could go ahead and select right here under this arrow to open Jupyter Notebook, or you could go ahead and select it down in the window down at the bottom. Windows, all you'd have to do is type in Jupyter. Now, before we do that, let's get something to work with. Let's get something very basic for somebody who wants to have a first exposure to Python and Jupyter Notebook. And so this is my GitHub account. If you go to GitHub, if you do a search GitHub, I think it's Geostats guy like this, and you go like that. That gets you to my GitHub repository, and you'll see you have a bunch of different repositories, 30 different repositories, a lot of content that I put out there for people to be able to use. And so Even if you're interested, I even put out Excel numerical demos. So maybe you're not super into Python yet, but you want to figure out some fundamental statistical concepts like hypothesis testing, confidence intervals. Maybe you want to understand the chi-square distribution, how you make one. I have a whole bunch of spreadsheets to demonstrate that. I even have one that does variogram calculation and kriging for geostats. So that's enough about that Excel. Sorry about that. Under my Python numerical demos, I have a whole bunch of workflows that are fundamental basic types of approaches going to more advanced geostatistical approaches like simulation and kriging, post-processing, volume variance relations, spatial bootstrap even. And then I have a whole bunch of workflows here for machine learning, for my machine learning course. Okay, let's go ahead and pick one that we can work with just to get started with perhaps just basic data loading and display. I think that's a good place to get started for today. If you make it through that, you should feel pretty accomplished. Like, that's pretty awesome. So I have one called Subsurface Data Analytics, Basic Data Loading and Display. Now, if you want to get this content and use it, what I recommend is just go ahead and clone or download. Click on clone or download and download the zip. When you do that, you can go ahead and save the file. And if you do that, it'll save a zip file with all of these workflows in Jupyter Notebook right to your hard drive. Once you've downloaded that, we can go ahead and open it up. Now, I got to move myself. I'm in the way there, so I'm going to put myself on the side there, and we can go to where it's downloaded, and we can open that up. We open it up, and we'll find it, in fact, is a zip file, and we want to work with the basic data display one right here. So we'll copy that out of that location. Now, where are we going to put it? The best place to put it would be in your user directory. Now, I've already done that, so I don't need to do that right now, but you could navigate to, C drive /users / your name, and then you can make a folder. And so whatever your account name is, my account, and then it could be like, let me just make this clear, my account name, and then you have a directory, my directory, and you make that directory there, and go ahead and put the file in that location. Now, you're also going to need a data file, but let's go ahead and get started, and then we'll play it by ear then. Okay, so now we've downloaded that workflow, and we need to go ahead and open that up. Let's do it by just going down to the bottom here of the screen and typing in Jupyter. We have Jupyter Notebook. Let's go ahead and open that up. Now, why did we copy this into your user folder? And the main reason is I find with Jupyter, it makes it easier to be able to get access to it. So this is what just opened up when I ran Jupyter and Jupyter Notebook as I get to this loading page. And so I have options. One option is I could just make a brand new workflow, and I could pick which kernel to use. Now, you've downloaded the Python 3.7 Anaconda, so you automatically have the Python 3. I'm a fan of R. I love R. What can I say? So I have the R kernel too, and I do a little bit in R2 in Jupyter Notebook. So now what we can do, because of the fact that we've done this, we've put the file in our folder, and the folder I used was PG383, which is the folder I use for my graduate level class in machine learning. And I have it right here. So I have this workflow here. I just click on it. When I click on it, it will load it up into Jupyter Notebook. Now, what's super cool about this, it's all web-based. We've got this workflow, and it's all divided up into blocks. And so let's just take a look at these blocks. I can click on a block, and you'll see this block at the top is all text. It's documentation. It, in fact, is what we call Markdown, which, if you ever heard of or worked with LaTeX, is a kind of a watered-down version of LaTeX. It's got a lot of very similar notation. In fact, if you double-click on it, you'll see this is what I actually typed in. And so I was able to put equations by bracketing in with dollar symbols. You can even use larger full-line equations that are centered. You can use links. Here I built hyperlinks saying Twitter, and then this is where it goes to, my Twitter account. So you can build up a really nice looking form of documentation. At any point, I can click in the window and click Run at the top, and it will compile it back into the nice documentation I had. So we got the run button here at the top. So we can go ahead and scan through our workflow and we can run block by block. Now we have documentation, we also have code. This code is Python code. Now at any point you can change a cell between different types, code, markdown, or what the two that I basically work with. And so you could switch it between the two. Right now let's leave that as code. And so this is our first Python code that we could run. Now, what's interesting here, it's very straightforward. Python is a giant language full of so many packages that are available to you, and each one of the packages will have functionality. Really, usually it's a set of functions, maybe objects, that allow you to be able to accomplish or build your workflow. And so these are the specific packages we need for this workflow. Now you'll notice they include OS. It's because I'm old-fashioned. I like to set the current working directory. I like to specifically control where files are going like that. So I like having OS. By importing OS, later on in my workflow, I can put OS dot and access the OS functionality for the operating system. NumPy is your friend. It is a very well-known mathematical package for dealing with arrays of data, to be able to work with matrices and arrays. So we have NumPy, it's beautiful. We'll import it as NP. Everybody else in the world does, we'll do it too. So now when we need to use NumPy functionality, you just type np dot and you can use any function from NumPy. The world of brilliance has just entered your office. It's amazing. Pandas is well known for tabular data tables. Very fast, efficient, great ways to work with data tables. You need data tables, everybody does in geoscience. You're going to need NumPy for gridded data, maps, and three-dimensional models, and you're going to need pandas when it comes to gridded data. Maybe you have some type of sampling, local sampling, X, Y, feature, that would be tabular data. Now, Matplotlib is the really well-known methodology for producing graphics. Now, there's other packages that do it too, but we'll stick with the simple basics of Matplotlib. We'll import PyPlot, which will give us a bunch of the component of Matplotlib that gives us a bunch of plotting capability, and we'll import it as PLT. And GeostatsPy, the geoslib component of it, has a bunch of functionality that we'll use. It's basically a Python version of geoslib, the geostatistical library. So the plotting functionality like location maps, histograms, scatter plots, and so forth have been re-implemented with the same type of arguments and structure as geoslib. It's kind of a nice bridge for those of you who may not be ready to do a bunch of Matplotlib on day one. So, and it's very compact. I like it. I use it. All right. So now we've actually loaded up OS, imported OS package, so we can use the change directory operator, or function I should say, in order to change the directory. And the only argument it needs is going to be the directory. Now, you had set the directory with your data to be like users. For me, I have my my other information. I won't put that in right now, but I also copied it to this generic directory in here in the C drive, so I'm able to go ahead and just run that. Now my current directory, what happened? I got an error. Interesting. So let's look at it. It says name OS is not defined. And so what's happened here is that up here in the code, we define OS. We say import OS. So now OS should be accessible to us. But I never clicked on the block and said run. Until you run the block, it hasn't happened. These variables are not set. I do not have these packages loaded. NP does not point to NumPy. OS is not accessible to you. So I got to go ahead and run this block of code. Now, when I run the block of code, I want you to pay attention to this circle up here. So I hit run. The circle is full. The code is being executed. No news is good news. No error. Seems like nothing went wrong. We've in fact imported these packages. Now, if you want to be a little paranoid and you want to figure out if the package has been imported or not, let's go ahead and do a little test here. So we can go ahead and say np _version __, and this should tell us which version of NumPy we're working with. It's good. It looks like it was imported. We're good to go. Okay, so now we have this functionality available to us. We can now run this code right here and change our current working directory. Now, anytime I try to load or save a file that's going to that directory, I can change the directories at any time. Now, you could always put the full path in any of your calls to read or write files. I like changing directory. It's kind of maybe something that makes me just feel comfortable. Now, you can see we're going to load in some tabular data. In order to load the data, we're going to use the built-in function for pandas, which, remember, pandas, we said import pandas as PD. So we use a command that says pd.readcsv. That's using the built-in function for reading a comma-delimited file, and all we have to do is give the name. So we're going to work with a file that's called 12_sample_data.csv. Where can you find that file? If you go back to my GitHub account under GeostatsPy, and you look at my repositories, I have a repository called GeoDatasets. And right at the very top of GeoDatasets, there is 12_sample_data.csv. So you can go ahead and do what you did before, clone or download that as a zip file, grab that data file and put it in your working directory, and you'll be good to go. Now, what does that file look like? Well, I have the file, I'm pointing to it on the other window here, and let's just open it up. It's a CSV file, so if you double click it, it will automatically open directly into Excel if you have Excel loaded on your machine, and you can pan through it. So what is it? It is a set of well data with XY locations over a 1 kilometer by 1 kilometer area with facies, porosity, permeability, acoustic impedance averages over an interval at those locations, and there is a good number of data here. It is about 826 wells to work with. So that's a nice little data set to work with. Let's go ahead and move that off to the side, but we can go ahead and import it. Now I want to show you something first. We're going to import it, don't worry, be patient, we'll get it. But let's give the wrong name. Let's cause a really kind of a big error to happen. So pandas, PD, read the comma delimited file, the wrong name. Okay, so this, I assure you there's no wrong name file in my folder. So when I run that, look what happens. Now, to someone who's not a person with experience in programming, this is quite an intimidating result. Look at what's happened. Look at that. There's a lot of kind of stuff going on. And so I want to help you understand that this is what's known as an error trace or a traceback. And so what it's doing, and I spent years programming in C++, and I've seen lots of this in those environments, is that it's showing you what did you do, and then where did the machine go through all the different levels of code into one method, into a package perhaps, and then one of the functions, and then the function it went to something else it called. It's showing you the trace of where it went until eventually it messed up. It didn't work. There was an error. And so this is starting in your code, line number 1 right here. That's where I made the mistake. And so this is where you look. Look at the line number, see what you did that caused the error, and then you can go through, go right to the end, and right at the very end, it'll tell you what the error was. This file does not exist. There you go. So when you run into errors, start at the top, see which line of your code caused the problem, go to the bottom, see which error, what it was the actual error result or message. Now, if you got more into coding, or maybe you're developing your own package, like I've been doing over the last year, you may want to go through this and figure out, oh, it went into this function, this function, this function, and it'll help you debug. Python is assuming you are a programmer, that you want it, well, you're using Python, you are a programmer, right? And so it's assuming you know something about programming. And so it's giving you all this information. Okay, that's enough of that. That was a bit of a tangent, but I think it was helpful. Let's go ahead and read the data file in. Okay, we'll go ahead and run this line of code. Look what happened. Nothing. Well, no news is good news once again, no error. So I'm going to trust that df is a variable representing a pandas data frame, which in fact is this tabular data set. That would be wonderful. Well, I don't know. I'm not that trusting either. Let's go ahead and find out. DF has a built-in command, or DataFrame has a built-in command where you can preview the top rows. It's called head. And so we can go ahead and run that. Let's go ahead and run that line of code. And look, ta-da, we get a really nice preview of the table. We got the indices for the wells 0 through the n-1 wells, X, Y, facies, porosity, permeability, and acoustic impedance. Now, I want to show you something. Every time you have a function like that, you're going to have parameters. Now, there was no parameter I have to give here because it has a default parameter. But at any point, I can hit Shift-Tab. And if I do that, it will actually get me to the doc strings where I can see the documentation for the function. And it'll tell me what I need to put into it. Now, the default is n equals to 5. In other words, give me the first 5 rows. Python is a zero-indexed language, so it goes from 0 to 4 of the elements within the array. Okay, or in the table, I should say, the rows. All right, so if we hit the plus symbol here, you can actually look at, expand, and see all of the doc strings for that function. And immediately you can see it's not a big deal. We can just set n. So let's try that. So we can go here and say n equals to 13, my favorite number, and we can rerun that. And now look, we get the 0 through 12, records are shown right now. So the first 13 are shown. Okay, so we can do that. We can look at our data. That's pretty cool. Now there's a lot of really cool stuff built in to Pandas DataFrames. And one of them is that we can actually directly access the elements, or I should say the features within the data frame. So data frame, and it is a capital X, is our X coordinate. If I type this in, what I'll actually get is a series, a Pandas series, with all of the X coordinates of all of my data. That's super cool. Now, what is the type? If you want to really know what it is, I use the type command all the time to figure out what is this thing I'm looking at. If we do that, it is a Pandas series. Now, every once in a while, you run into a function that doesn't understand Pandas series. It needs something more general. So within the Pandas series is a one-dimensional NumPy ND array. How do you get access to that? Type values. If I do that, now I'm dealing directly with the ND array. It's an ND array. What does it look like? The great thing about Python, just type the name of the thing in and just run and visualize it. It is a one-dimensional array. It has all of the values that are in those, 600-700 records of wells with averages, and those are the X locations. Now, if it's an ND array, you can always use the shape command to see what are the dimensions. It is 480 by 1, effectively. It's a one-dimensional array. So we just got 480 elements to look at in a one-dimensional ND array. So that's cool. We can extract that. Now, if we want to, since we can extract it as a set of values, now NumPy has all kinds of functionality whereby you can calculate statistics on an array. And so if I want the minimum of that, I just type that in and I get the minimum. 0 is the minimum coordinate in the X direction. I could also type in maximum, and I can run that. It goes to 980. Now, I told you it was a kilometer by a kilometer. This is in meters. This is 0 through 1,000 meters, X and Y. Spoiler alert. Okay, so now we can do any types of, there's so many statistics we can do. We can do a mean. That would be something that would be kind of interesting too. Or you could do a standard deviation, and we could go ahead and run that. So you get the point. Now, we can use the print command too. And the print command is super useful. I can go ahead and just tell it to print this output. This is the standard deviation. Now, that's not very much magic because we've already done that. We already were showing it. But that's useful because if I have multiple things I want to show, I have to use the print command. Otherwise, it only shows the last thing that I output. And so by doing this, I force it to show me both of those lines of output. So it's good habit to use print commands. Now, that doesn't look very nice, so you can go ahead and do something like this. The mean is, and you can concatenate. So what this is a string. You tell it to print this statement right here, but then you have to turn this into a string too. And that's a cool thing about Python too. You can just recast things, and now it's a string, and so when you concatenate with the plus symbol, we get this output right here. Now you might be concerned about the way it looks. You want to clean it up a little bit. You could at any point say, well, round it to 2 decimal points. Now you notice the brackets highlight, and so that helps me put the right number of brackets back in when I'm finished with my command. And I just realized I created an error. And why did I make an error? Because when I round, I should be rounding the mean, and so I have to make sure that these brackets in here enclose the mean calculation, and then the result or output from that is rounded. Now this bracket is in red because I have too many brackets. Now you can see green and green, and I should be good to go. And you can see, in fact, I am rounding this output. So I've taken so what have we done? This has gotten a little bit like a nested command, and that's a very cool thing with Python too. I take the data frame. From the data frame, I get a series. I use values to turn it into an ND array. Then I go ahead and use NumPy mean to calculate the average of an ND array. Then that output from here is passed to round. And round takes that output and rounds it, removes it, truncates it at 1 decimal place, because I put a 1 here for the argument. Now, of course, at any point, if you're stuck, go ahead and use a Shift Tab, and you can see the doc strings, and you can see exactly what's expected, a number, and then number of digits that you want to round. Now, there's a default of 0 digits. Let's prove that to ourselves. If I go ahead and remove this number, and I rerun this command, so what's happened now? It has rounded it to the nearest whole number. Okay, so we can go ahead and then we can take and convert that all to a string. We can concatenate it with this string, and we get our nice little command there. Well, we'll do the same thing right here, and we get a nice x-coordinate, y-coordinate, porosity, min and max. Why would we want to do that? Well, I want to set the min-max so that when I visualize or plot, I have a reasonable display. Now, I don't necessarily want to have my map go from exactly the min-max of the data. I may go ahead and decide 0 through 1,000 meters, 0 through a kilometer. That's nice. Porosity, I'll put it as the min-max. Now here's a color template. Now that's a lot of fun. Within Matplotlib, we've access to a whole bunch of different color maps, CMs. So we can go ahead and say, let's make our color map CM Inferno. Why? Because it sounds wicked. No, because Infernal is a really good color bar from the standpoint of colorblind and people with different issues with color, because the tonality and the intensity vary together. It's not like a rainbow scale where you'll end up in a situation where if you are colorblind, you wouldn't be able to tell the difference, right? And I think it does a pretty good job of not creating biases that you often see with rainbow and other bars. So let's go ahead and run that. I got all of that from listening to Matt Hall talk about the topic and others on Twitter, so trying to learn about that. Now, why I imported GeostatsPy is because we're able to create a location map with 1 line of code. It's not a big deal. I literally took Matplotlib, built a really nice looking location map, turned it into a function, and then I'm able to run it with this one function call. Now, I also like it because it uses the same parameters as you would expect from GeoSlib, this geostatistical library. So it has, first of all, what's the data frame with the data? What's the X feature? We just give the name of it, X, which if you go back to our table here, X, Y, and porosity are the features we're concerned about. Not a big deal. So we come back down here, the X, Y, porosity, the min, the max in the X direction, the min and max in the Y direction, the feature min and max, the title of the plot, the X-axis label, the Y-axis label, the label on the color bar, the color map, and then a name of a file that will be created automatically. So this is kind of one-stop shopping. Let's go ahead and run that. You can judge whether or not you think this is an awesome looking location map. I think it's not too bad at all. Now, you might look at this and go, well, I don't like that color bar. I think it's a little too awesome. And okay, I get that. Maybe you don't want it to be so, it's pretty high contrast, or what? Plasma is a little more gentle maybe. So there's a bunch of them. Look them up. You have different color bars to work with, and you run that and you get the plasma color bar. You see it's not quite as contrasty. It's fine. All right. Now, if you had, maybe you're thinking, come on, Perch, we used GeostatsPy, it's your package, you're just trying to get us to use it. you could go ahead and just go to Matplotlib and functionality and make a plot. And so the plot we'd want to work with is the scatter plot. And so I won't go through the details of building this from scratch, but you could go ahead and run this line of code right here, and you would get a basic scatter plot with no labels and no legend. And so the remainder of this code is all about setting the labels on X and Y axis, setting the min-max so that you have control over exactly, instead of just the data min-max, setting the color bar orientation, the tick spacing, and so forth. And so, so this is exactly what would be required to make it. Now, another thing I do is I like this subplots and adjust command with PLT, with Matplotlib, PyPlot. And that is, I really like the way I'm able to explicitly control the size of the plot in a very nice manner. I know some people don't do it this way. There's other ways to scale your plot. It's just, I'm kind of entrenched in that. So let's go ahead and run that. Now you look at that, it's really the same plot. It's got a different scale. We could rescale it, but that is it right there. And that's all the code you would have to do in Matplotlib. That's a nice little location map example for you. Okay, so what if you have gridded data? Oh, gridded data is really cool too. And so we have another data set that we'll work with. It's called 12_AI CSV. And that file is also available on my GitHub account under GeoDatasets repository 12_AI.csv. Now, if you're curious what that file looks like, well, go ahead and make sure you download that and put that in your working directory. But if you're curious what it looks like, here it is right here. Ah, amazing, isn't it? So basically what it is it's a table of 100 by 100 of values. It's a regular spaced map of values sampled at every 10 meters for acoustic impedance. So that's pretty useful to us. Let's go ahead and load that in. Now to load it's not a big deal. We can load that two-dimensional mesh that's comma delimited. We just got to tell it that the delimiter is a comma. And if you look at the raw file, you can confirm to yourself that it in fact is a bunch of commas. Now what did we just create? Seismic was loaded using NumPy. What do you think it's going to be? So let's go ahead and just take a look and see what's the type. Type seismic. Okay, let's go ahead and run that. It's an ND array. Well, that's cool. That makes sense. What do you think the shape is? Let's go ahead and check it out and see what the shape of this ND array is. 100 by 100. So it's loaded it in as a two-dimensional array, ready to go, ready to visualize, ready to work with. In fact, you can just type in seismic and take a look at it. It's going to truncate it because it's 10,000 data values. It'd be kind of a nuisance to try to look at them all at once. Well, let's go ahead and do some visualization. Well, to do a visualization of a mesh of data or gridded data map, we have to tell it where it is in space. We got to georeference it. And so it's just the ND array does not carry information about the size of the cells, the origin. So we have to put that in. The min, the max, and X and Y, the cell size. The min and max for the variable of interest. We could have just put the poor min and max. That's what we're going to use here. And the color bar we're going to use again. So let's go ahead and we can run that and take a look at what we get as far as the pixel plot. And look, it doesn't look bad at all. And so we have our acoustic impedance. We can see that there are some interesting features to it. A bit of some noise. We could suspect there's some noise. That may not be a natural geologic phenomenon. Okay, I won't go too much into interpretation or discussing it. Now, something I should have said before when we took a look at this file, and something I should make clear is that this is a two-dimensional array. And so how does it sort? How does it order this array? Well, first of all, I can do this, 0, 0, and this would give me the first element within this array. So I run that, and I get that first element in the array. Now, how does it work? Well, Python arrays will read across like you're reading. So if we go to the very top of this array right here, the first column, the first row, that's 0, 0. Now the first number is going to be the row, this top row. The next is going to be the column. So 0, 0, that's that value right there. It came back and said about something like 2,500. That's not too unbelievable. That looks about the color we have right there in that square. just guesstimating. You could also do this. If I do, and I remove that index for the column, and I run that, I will in fact get the whole first row. And so this set of numbers, 100 numbers right here, is all of this data going across the very top of this map, the first row. And so I can do that. I can look at specific subsets of this data set. Now, I can also get a little bit more creative about it. I could say I want the first 2 rows. And if I go ahead and I run this, I've removed the column index, and I've said, just give me the first 2 rows. Now this slicing, the colon means take 0, 1, up to 2, but don't include the row number 2. Now remember, Python is 0 index, so the first 2 rows are 0 and 1. And so this is the first row. And then you see the brackets here. This is the second row. Okay, so I can access values within this matrix by doing that. Now, at any point, I could go ahead and I could just say, well, let me see the value at the center of this 2-dimensional ND array. So run that, we got this value right here. And I could say, I could reset it to another value. I could say it's equal to 999.9, and I could go ahead and run that. Now, if I've done that, what will actually happen is I've reset a value right at the center of my mesh. If you look really careful, do you see that value? It is exceeding the maximum value. I put that effectively a hole right in my data set. So you can interact with your data frames, you can interact with your grids, you can manipulate them, you can visualize them, and so forth. There's so much more. I've just really scratched the surface and suggested that you can load tabular and gridded data into Python and then interact with it as a data frame for the tabular data, and for an ND array for the gridded data, maps and 3-dimensional models, 2-dimensional models, and so forth. Now at any point, because you're doing things, you want to save it back out. And so data frames, remember we could read a CSV, we can do 2 CSV. And if you were to edit it, you can go ahead and save it back out. That's very useful. Also, if we're working with our grid data and we make changes to it, we're able to save it out as a file that can be then read back in. Now we can save as binary, we can save as comma delimited. There's so many different ways to save. And I have if you look in my GitHub repository under my Python numerical demos, I have a set of functionality to assist you in working with data frames and ND arrays specifically. And they have a lot of information. In fact, they tell you how to read and load a variety of different formats. They prove that if you load and save and load again, it's the same thing, closing the loop. Anyway, I hope that this was helpful to you. This was a very basic introduction to Python, working with geodata, and working with Jupyter Notebooks. Now, I'm Michael Perch. I'm a professor at the University of Texas at Austin. I'm happy to discuss anytime. I have all my course content online, and you can see my information being shared, GitHub, YouTube, these lectures, and also my Twitter account, GeostatsPy. All right, I hope this was helpful to you. Thank you very much for watching.